So we got a few problems here dealing with the graph of a logarithm. And in general, the graph of a logarithm looks like this. That would be y equals, since we're doing natural log, we'll say ln of x. It's got an x-intercept at 1, 0. Notice it doesn't have any horizontal asymptote or y-intercept, but it does have a vertical intercept. That's in general. Now, we're going to be dealing with ln of x minus 4. Well, we know from our transformations of functions, this will shift the graph 4 to the right. Now, in general, ln of x, so this graph here has a domain of all reals. Excuse me, not a domain of all reals, a domain of x greater than 0 and a range of all reals. Okay? Just put this where you can see it. And the domain is x greater than 0. That's in general. Now this has been shifted 4 to the right, which is going to shift our domain 4 to the right. The other way to think about it, and this will be good because we can generalize this, you need what you're taking the natural log of to be greater than 0. So x minus 4 must be greater than 0. And so, except this is not a domain question, excuse me, doing it again. Range. Shifting it to the right 4 is not going to change the range. And the problem with this problem, or what can be tricky, is if you graph this, you don't really see it. In general, the graph of a natural log or a log has a range of all real numbers. So shifting it to the right is not going to change that. Now, which of the following is an x-intercept of f of x equals ln of x minus 4? Well, this x-intercept has been shifted 4 to the right, so it's going to be at the point 5, 0. The other way to see that is to set your equation equal to 0 and solve. ln of x minus 4. ln is base e, so rewriting this as an exponential, e to the 0 equals x minus 4. Anything to the 0 power is 1. Don't forget that. I hear 0 a lot. Anything to the 0 power is 1 equals x minus 4. Add 4 to both sides, you get x equals 5. So there's a couple different ways of looking at that one. The y-intercept of ln of x minus 4, that's the output when the input is 0. So if we do that, ln of 0 minus 4 equals ln of negative 4, which is undefined. Well, because we're shifting this to the right, it's not going to hit the y-axis. If we had shifted this to the left, if we were doing ln of x plus 4, we would have had a y-intercept. So no y-intercept. Which of the following is a vertical asymptote of ln of x minus 4? Well, two ways to look at it. Once again, this had a vertical intercept at 0. Shifting that 4 to the right would be the line x equals 4 because it's vertical. The other way to think about it is your vertical intercept will be, your vertical asymptote will be at whatever x value makes what you're taking the log of 0. So where x minus 4 equals 0 will be our vertical asymptote, so it's at x equals 4. So there's a couple different ways to solve a few of these problems.